Hi, everyone. Welcome to the Open Data Foundation office hours. I'm here for part 3 with Daniel Parks. How are you?
Hi, hello. I'm doing okay. A little
Okay,
bit.
so tell me about part 3. We've done part 1, part 2. Can we do a little recap before we get started?
Yeah. So in the first two episodes, we went a little bit through, in the first one, the architecture of the external Ceph that we use with Metro DR.
Right.
That, again, is like our RPO zero solution, or no data loss disaster recovery solution that we have. No, so in the first one, we covered the diagrams and a little bit the architecture in detail. In the second one, we went a little bit more into the terminal now, and we were showing a little bit of the Ceph configuration, the stretched Ceph that we use for our storage in detail. And now in this third episode, the idea is to go through a demo of the DR of an application. No? So we are going to deploy an application, and then we can fail over that application to the other side, and we can check how we are actually not losing any data in that failover, because, as we said, Metro DR, synchronous replication, that is the one that we are currently using.
Okay. So where do you want to start? Should we do you think we need to do a recap of the architecture and the end of part 2, which was details
Yep.
on the configuration? I know this time we're going to use ACM, right? Like
Yep.
we have some parts that we haven't actually seen in the other shows. So you want to
Yep.
share your screen? Let me know what you'd like to do.
Yeah, I'm going to share my screen, and we can go first to the diagrams just to get a little bit of context and go through what we already covered, and then we can jump into the ACM part of things.
Perfect.
So I'm going to share my entire screen, because we're going to go backwards and forwards between the terminal and also the UI. So can you see it, the diagram? Okay, my
Yes.
screen, fine. Okay, so this is where we left off on episode 2, or maybe we could say that one step further. No, we left off at this point. So just to get a little bit of context, on episode 1, we covered the stretch Ceph cluster deployment. That is really what we have here. We have two sites, or two data sites, where we have our Ceph clusters and nodes running. And on a third side, we have the arbiter. That the arbiter is really the monitor, the tiebreaker site that is in charge of keeping the quorum when we lose one of our data sites.
Okay.
So what we did in the last episode is that we actually used the ODF operator to connect our OCP clusters to this stretch Ceph. So we did a small demo where we showed how we were connecting our OCP cluster through ODF external to our Ceph clusters. That gives us the possibility of using the storage classes provided by Ceph. So we have block, we have shared file system, and we also have Rados gateway, or the S3 endpoint to use. We configured one side, we have now configured the other one. So really we have both sides connected to the same stretch storage. So both OCP clusters are connected to the same stretch storage. Now this is what allows us to have actually synchronous replication, because when one client is writing to a file or is writing an object, we are not going to get the acknowledgement, the ACK, from Ceph until it is written on both of the sites. So until it's written in 4 replicas that we were covering on the first show. So we are making sure that we have 2 replicas on Ceph nodes or on the OSDs on site 1, and also on the OSDs on site 2. So we have 2 replicas on one side and 2 replicas on the other, so we can tolerate like a full site failure, and we will still have access to the storage without any issues.
One quick question, from a high level, just so this is clear in my head, there are items that require quorum, right, which need all 3, like
The
wow,
monitors.
it's in your diagram. I don't know if I can see it. So there are items that require quorum to decide which cluster, which parts are live. there are items that are hot cold,
Mhm.
right? There are items that are load balanced. Just to think about it in total. So for
Yep.
instance, and I'm having trouble remembering what's the thing that's hot cold that's only live on one side until failover happens.
Yeah, the manager, for example, that we have here is active passive. The job of the manager is really taking care of the metrics, gathering metrics, and also it gives us the UI, the web UI, where we can also check the health of Ceph and also do Ceph configuration through a web UI. And it also enables us to use certain modules as the Ceph orchestrator module or Ceph ADM that I was showing on the last show. That is really what we use to maybe add new nodes to Ceph or add new OSDs to increase the capacity. So that was active passive, as you mentioned. We also have RGW, Raiders Gateway, that's the S3 endpoint. And this is really an HTTP RESTful API. So we can load balance it. We can have it active and just load balance it however we need with an external load balancer or what. There are many possibilities there.
Right.
And then we have the monitors that are really the most important part to have quorum, that we had 2 monitors on one side, 2 monitors on the other side, and then the tiebreaker monitor on the arbiter side. So even if we lose a full site, we will still have quorum because we have 3 monitors available.
Okay, cool. Thank you. Yeah, perfect.
Yep. So the idea of what we're going to cover now is we're going to deploy an application. I already have it running, but I'm going to show you what it looks like in ACM. It's just a simple application. So we're going to try and cover this part. Here in this drawing, we also have a global load balancer. This is really so we can load balance the client requests to our applications between both of the sites. So if we have a site failure, the global load balancer is going to be able to redirect the client request to the other side. So this is what we are trying to achieve in this first step. So we're going to show a little bit and we're going to move forward, and then we can come back to the diagram and keep looking at what we're going to do. So here, what we have already deployed is an application through ACM. It's a very simple application that is using, so it's stateful, it's using a PV because it has MongoDB. So it has a database running, and the application is Rocket Chat. That the Rocket Chat is very similar to any chat application that you could think of, like Google Chat or Slack or something like that, in that kind of way. And the thing that it does is that each message that you write into the chat is actually stored into the MongoDB database. So our objective today is to actually check that when we do a failover after a disaster, we don't lose any of those messages that have been sent before we actually had the issue or the failover, or we triggered the failover.
Nice. Okay. So this is already set up. You've already installed it. Everything's ready to go.
Yeah, at least the ACM application, not so much all of the DR stuff, because you can perfectly have an ACM deployed without protection, without DR protection, and then you can say, okay, I want or I need to protect this application. And then you can go ahead and protect it without any issues. So what we have done is deployed an application without any DR, and now we are going to configure DR for that application.
Gotcha.
So let me just show you the app very quickly in ACM. Make this a little bit bigger. So as we mentioned, the app is called Rocket Chat, and we can just check here the topology. And here I just wanted to show that it actually has a persistent volume, persistent volume claim, and it has a couple of pods running. One is MongoDB, and the other one is the front end for the Rocket Chat application. This is actually, if I get the route and I go into my application, this is what it looks like. Let me also make this a little bit bigger.
Thank you.
So what we're going to do now with this application is that I have a script that is going to be sending messages every 10 seconds. It's going to send a new message. So let me just run that script so we start generating messages.
Okay.
Also, we're going to give in the description of the show the repo where you can use this same example, no, that I have been using here. So let's wait for 10 seconds and see if new messages are going to be generated. Here should be message 0. Okay,
Yep.
So here we have the new message incoming.
Perfect.
Sorry. So the idea here is that we're going to see the message number, and also we are going to see the time, or here, no, we have timestamps of when was that last message available. In that way, we can compare if we have lost data, and also, so that will be the RPO, no, the actual data loss, and we can also check the RTO, no, the time for the application to be available on the second site. So we're going to be able to check both of these things with our application that we have running. Okay, so currently our application doesn't have any DR configured, and that's the first thing that we're going to do. With ACM and ACM 2.6 and the new version, you get here a new tab, as you can see, that is called Data Services, where we can configure data policies. And I'm going to explain this a little bit in a moment. But what we're going to do is create a new policy. So what we actually do when we create a policy is that we specify 2 clusters. So really, we want to choose both of our data sites or an OCP cluster in both of our data sites. So we can create like a relationship between both of them. And then we're going to have applications active and passive on both of these clusters as needed. No? Okay. This is creating a DR policy is a thing that an administrator would do, like an OCP administrator would do. But then a developer can have his own application as a developer if we give him access, and he can choose if he wants to protect his applications and with which policy he wants to protect his application. No? Because as we're going to see now, let me just check both of the clusters that we want to use. And straight away, what it's doing is you can see here that it's automatically detecting that this is an external storage cluster that is deployed in cluster 1 and also on cluster 2. Okay. So it's automatically selecting that we're using synchronous replication, that we are using Metro DR. But the important thing here is that if we were to select 2 clusters that were using regional DR, we will get asynchronous here, and you can have everything with the same user experience. No? So on the same UI, you can have your synchronous clusters and your asynchronous clusters and your asynchronous policies. Okay. This is great because then if you have permissions, no, and you are the developer or the admin for your application, you can come into here, and then you can select whatever policy fits better for your application. No, it could be asynchronous, it could be synchronous, depending on the criticality of your application. So as you can see here, this has been validated and the replication policy is sync, but we have 0 applications using this policy. No, we have just created it. So at the moment, there are no applications using this. Let's say that we are
Can I ask you a quick policy question? Just a quick one. Yep. Can I layer them up? So let's say I want to do for local failures, do use DR sync, but then if I'm beyond that, I want to do synchronous. Can I stack them in that way?
No, not at the moment. At the moment, when you select one policy for your application, so you can have different policies. Yeah. Okay. Once you select the policy, you're not going to be able to choose another one. No, so it would only let you use one.
I was thinking like based on how bad the failure is, right? Like if it's local and if it's regional, like going further out in order. Okay, but that's cool. All right. Sorry.
Yeah, that could be a good point. No, that you could have like your Metro DR for everything more regional and having 2 sites that are quite close together, and then you could have your regional actually sending the data also outside or to another geo. So let's say that now we are a developer, we are from the team of Rocket Chat, and we want to apply DR to our application because it's very critical. So we will just go here, apply DR policy, and we will select the application Rocket Chat. And now we have one connected application. Going a little bit into the details of things that we needed to get to up to this point. No? So doing a little recap, and just to speak about the operators, the only thing that I needed to do to get to this point that I'm showing right now is actually on my ACM cluster, that if you remember I'm using the Arbiter side. No? So on this OCP cluster,
okay.
that I call it the hub. I just needed to deploy the ODF multi-cluster orchestrator. And when we deploy this operator, it gives us this new CR, this new CRD, that is the mirror peer. No? And once we create, as I just showed here, now once we create a policy, a certain amount of things are going to happen. No? And let me show you on the terminal just a second, so we can take a look. This is just for details, no? Because everything happens out of the box automatically, and you don't really need to know this, but I'm just going to show you a little bit to go into details just in case it can help when somebody is actually troubleshooting. So here, I am going to use this command that you can see, occonfig use context hub. The use context is that I have my 3 clusters specified with 3 different contexts. No, I have the hub, that is the Arbiter side. I have cluster 1 and cluster 2. So you're going to see that I'm going to use commands to jump and to run things on one cluster on another. No, currently I'm going to run it on the hub, and what I wanted to show you is get mirror peer. So we should have a mirror peer here created, and I'm just going to get the output in YAML to show you a thing. So really, a mirror peer is a list of items, and each item is actually a cluster where we want to create a relationship between both of the clusters. No? So we have cluster name, cluster 1, cluster name, cluster 2. And for each cluster, we have an storage cluster reference. In the case of ODF, we always use the same names. But if, for example, you were using Rook, that you can change the names of the cluster and you can have more than one cluster, then this would be actually a thing. No? When using ODF and when using the DR from Red Hat, you don't really have to worry. No? But just to mention here, items, we have cluster 1 and cluster 2. And what we are telling it is that the relationship between both of these mirror peers is going to be sync. So we want to configure synchronous replication. That is, if you remember, is very similar to what we had when we created the actual policy. No? So as I said, you don't have to touch anything here. No, this is just a result of doing the actions that we took in the UI just to get a little bit of information.
When you went to configure ODF multi-cluster on the hub, did you need anything other than keys? Like, what, is that the only information, like the user, the top level user and keys to go
here? No, you mean at this point?
Yeah. Like, what other information did you need? Just, do you remember? I don't know if you did it today.
Yeah. No, you don't have to do here, because the object that you have is mirror peer, and so you don't have to do anything. You just have to deploy the operator.
Okay.
And then you get this object mirror peer, but the mirror peer object is created automatically for you.
Okay.
Once you actually create this data policy that we created. No, so once you create it, everything is going to start happening on the background, and the mirror peer is going to get created for you. And as you just said, no, because the mirror peer also takes care of copying the S3 keys to all of the nodes. No.
Okay.
That's why we have here like manage S3 true, meaning that the mirror peer is going to take care of creating the OBC buckets that I'm going to show you right now, and is also taking care of creating a secret where you have the access key and the secret key, no, for those buckets that it creates. Why do we need S3, why do we need buckets? Because we store the PV and PVC metadata into these buckets. No? So what we are doing is that on each site, we are storing this data. No? So we are actually using MCG, we're using Nuba, and we're storing the information on both of the sites, because as we have two OCP clusters, we have two MCG instances, and we are copying the data. So we have it on both sites using these operators. So if I actually go into cluster 1C, I'm just doing the use context, I go into cluster 1C. Here we should have an OBC created. This is an object bucket claim. So here it is, for disaster recovery bucket. Everything is done for us out of the box. We don't have to worry. Everything is automated for us, But the bucket is created, and then the secrets are copied to the hub and to the other managed cluster for us. These buckets are important because we are storing, as I mentioned, in object storage, we're saving the object metadata for the PVs and the PVC. So really, we are not storing any physical data. It's just metadata. Okay, the physical data is actually on our stretch cluster between both of the sites. Okay, so other things to take into account that happen. When we created the mirror peer, there's also another object that gets created that is DR cluster. Again, if you want to use it, you don't really have to worry about all of those details. I'm just giving them to give a little bit of insight on what happens. And because the DR cluster, we're going to actually use it in a moment. So going into the spec, what we have in the DR cluster is, first we have one object per managed cluster. So we have cluster 1 and cluster 2. And here we are defining the CIDRs. This is really the IPs of all of our nodes for this cluster. So if I do an OC get nodes, this is just, sorry. So what we can have here now is actually these IPs are the IPs for all of our 6 masters and workers in our cluster. And the reason for having this is because we need to do fencing. We spoke about this in the other shows, but I will just cover it in a moment so we better understand why we need to fence the storage. So I'm just going to explain that. I just wanted to, before, speak about the S3 profile name. So really here, we are again just defining with this S3 profile the OBC bucket that we saw. So we are really making a relationship between the S3 profile name and our cluster 1. Cluster 2 is going to have another profile name with cluster 2 that is really going to point to each of the buckets that we have on each of the sites. So going just a moment back to our diagram, and so we can explain the fencing side of things. So right now, this is the picture that we have. We have deployed an application through ACM. ACM uses kind of a GitOps approach in the sense that it's reading the source from GitHub, and it's deploying the application on our managed cluster. Let's say that now we lose the OCP cluster, so we have a failure. We are going to speak about the OCP cluster, but we could perfectly lose the full site or just it's just so we have a failure point, so we can understand. So let's say that we have lost our OCP cluster, and then our application is going to be down. When I mean down is that it's not going to respond anymore. So our Rocket chat is going to stop responding. It's not working. We need to initiate the failover to the other side, to the new site. So again, we have to remember this. We already mentioned it, but you always have to initiate the failover of an application manually. So it's a manual operation. It's currently not automated. That there's work being done just in case someone would like to automate this kind of things being triggered through an alert or something like that. But you have to be careful, because it's quite delicate to move one thing to one side to the other, so you have to be very sure, especially when you're doing fencing. So at the moment, this is done manually. And what we are seeing here is the global load balancer is going to fail. So actually, the global load balancer, how you normally configure it is that you have like a health check against this app, let's say against the HTTP endpoint of the application. Because the app is down, the health check is going to fail, and it's going to stop sending traffic through this site. No, at that point you are not giving service, so you say, okay, let's start a failover let's initiate the failover of this application. The first thing that you need to do is fence all of these nodes, IO fence all of these nodes. Why you need to fence the nodes is because you have to be very, very, very sure that no one is accessing this data before the application starts in this other side. Because if this was not the case and you were not doing fencing, what could happen is that you could have the application running on both sides at the same time, consuming the same storage at the same time, and then you could have data corruption, because when you have the mount point mounted on both sides, you could have data corruption.
So the fencing prevents dual brain, right? You say no one's allowed to touch it. So how do you fence in this?
Yeah, let's go into that step. No, so here, as you mentioned, very important to fence, so we are sure that none of the applications or none of the worker nodes are able to access any of the storage. So you are completely cutting off all of the storage nodes. So how do we fence the application? Let me just check that this is still running. So we have our cluster running. Yeah, this is still working. Okay, so fencing.
One quick question. So to be more specific, are you saying that we want to make sure that nothing in cluster 1 is accessing any of the PVs or whatever storage that application, the Rocket Chat application, is using? Just to be very
that's an important that's an important thing, and it's a good point that you brought it up, because this is quite different from regional DR. With regional DR, we can actually fail over, let's say, the application from one place to the other, but you can leave the rest of the applications running. So it's really granular to the application level. Here it's also granular to the application level, but when we decide to fail over, we are actually cutting off the access to all of the storage. So all of the worker nodes and masters don't have access to the storage. So we will need to fail over all of our applications at this point. That's a big thing to take into account, that is different from regional DR, for example.
Okay. All right, I'm following you. Go ahead.
Yeah, so at this point, we need to fence this. Let's say that we are at this point. We have a failure, and we want to fence first the workers and the master nodes, and then we will run the failover. So what we're going to do there is, I have a script here, but I'm going to show you also, this script is also on the repo that we're going to share, but it's really very simple. Another thing to take into account is that in ODF 4.12, this would also be on the UI. So you're going to be able to fail over and fail back, relocate through the UI without needing to go to the terminal. But this is 4.11, and at this point in 4.11, we have to do this through the terminal. So what we're going to do. Yep,
okay, and quick question. So what you're essentially saying, just to make sure I have it right, is if a problem is detected if there are multiple apps on cluster 1, if one of them has a problem, then you fence off everyone and everybody fails over.
That's why
the philosophy being that the underlying storage has a problem from that side, that cluster's got an issue, we're going to ignore it and go to okay.
That's right. So you have to be very sure. When you actually take the decision to fail over, you have to be very sure that there's maybe not an issue with a single app. You are going to have issues with all of the apps because, for example, your OCP cluster has been corrupted, your OCP cluster is completely down, or even worse, your full site is out. So that's when you will take the decision to actually fail over, to the other side.
So sorry, one last question before you go on. So in this case, we don't want, so I remember in regional DR, we had a case where if you had an app one in one area, app two over here, you can have them fail over this way. There was like, you could choose the direction you would want things to fail over. In this scenario, are we more likely to say everything on cluster one is going to be primary, and when it fails over to cluster two in concert, right? Like all together?
Yeah, it could be, but it's not a requirement. Maybe it's easier to imagine it or to make it work, but you can still have applications on one side or the other, no? Because if you think about it, let's say that you have some applications running here and some applications running here. If you fail over site one to site two, okay, you're moving everything to the other side. If you need to move site two to site one, you're moving everything, no? So it's perfectly compatible to have some apps active on one and the others on the other one. Okay. The only thing is that you always have to.
All right. So if you have an app on site two and site one goes down, you fail over, all you've done, lost your DR target, but that's fine because the site's done it and you don't care. Okay, just making sure. All right.
No, that's great. And as you said, no. So the thing is that if you lose like the full site, you have to apply the failover and then move it over, no, and move everything together. Okay, so let's say that we have a disaster. Oh, the other thing that I wanted to mention is that you can also use relocate. So we have, let's say, two different actions, and I'm going to show that later. No, so you have the failover action where you're moving, you have a failure. No, so you use failover when you have, like in this example, no, one site is burning down and you want to move your applications. Then you can use failover. But there's also an action called relocate, by which you can move your applications from one site to the other without actually needing to fence anything, because that's like you are under control and there's not an error or there's not a problem on any of the sites. The only thing is that you want to move from one place to the other, and you can also do that using the relocate action. No? And the final thing that I would mention is that with MetroDR, you have to take into account the usage. That is, if you have a full site failure, you need enough resources on site two, so you're able to move all of your applications to all of the applications that need DR, because maybe you don't want to move all of them, only the very critical ones. You need to have enough space enough resources, enough space on site two, on the worker nodes, to manage all of the load that is coming from site one. So you have to take that into account and you have to work with that. Okay, perfect. So as we said, we have the DR cluster object that I just showed you a moment ago. Let me just show it again so we remember which one it is. The DR cluster one is where we saw like that we had the IPs of all of the workers and the masters and the profile. No? So what we're going to do is we're going to patch this DR cluster. Let me just clear this so we can see it a little bit better. So we're going to patch the DR cluster that I just showed you, that object, and we are going to add cluster fence with value fence, meaning that I'm actually going to fence cluster one. So if I go ahead and run this command, cluster one is patched. So now if I do a get, you can see here that I have added this line. I could also do an edit, no? And then I want to really check the phase that we can do like this. This is the same object, no? It's DR cluster one, and what we are checking is that the status of this DR cluster is fenced. So what is going to happen is that we are going to network fence. Let's say we're going to block the access to all of the worker nodes and masters to the Ceph cluster, and we can check in the Ceph cluster with the block list. You can see here that all of these entries have been added. No, so really what it's doing is telling in Ceph that don't accept any requests that come from these IPs. No, that these are the masters and the worker nodes of site one. So we are really blocking all of the requests from them during the time that we have the fenced enabled. Just again, to go into a little bit of details, if I go into cluster 2. So use context. I go into cluster 2C. I can also do here the network fence. So really what has happened is when I did the patch on the DR cluster on the hub has created this object on cluster 2C that is really saying fence. Now we can see that the state is fence. It has been successful, and it has fenced all of the nodes that I have in the list for the DR cluster. So I'm really cutting access to all of the nodes to the storage from OCP cluster on site 1. Once we are sure, as we can see here, that we are fenced, that we have fenced our storage, we want to fail over the application, so it actually starts running on the other side. And for that, we also can use a couple of patch commands. So we are going to modify the DRPC. Again, the DRPC gets created when we went to the UI and we added our application to the policy. If you remember, we selected Rocket Chat and we said, okay, we want to add Rocket Chat to the DR sync policy. So at that point, a DRPC got created. And let me just show you what it looks like before we actually patch it. Just a moment, because this is at the hub. So I change to the hub. And let me show you just a second. -A, because this is per namespace. Okay, so here in the DRPC, what we have is the DR policy that we are running. This is DR sync that we used before, and then we have the preferred cluster. So we can also do this command where we can see it even better without all of that information. So what we have here is our Rocket Chat application, and the preferred cluster is cluster 1. So what we're going to do now when we actually run the patch commands is that we're going to tell it who is his failover cluster. That is going to be cluster 2.
I was going to ask him, why is that blank?
Okay. Yes. Yeah, you could also add it and leave it. So that's the thing that you could do before.
Okay,
but normally on the documentation, we have it together, that you actually add the failover cluster and then you do the failover. So let me just get these commands. These are, again, patch commands of the DRPC. As you can see, that is the object that I was just showing a moment ago. And the first command is what we are going to add, that our failover cluster is cluster 2.
Okay.
And that we want to trigger an action of failover. You can see here that this action and it's failover. Yes. So we are initiating the failover from one side to the other. Okay, so while this is going on, let me just go into this diagram, and this is what is going to happen. So this is our previous state where we have everything down. Now we're going to failover, and what is going to happen is that ACM is going to deploy the Rocket Chat application on data site 2, and then ODR, that is our disaster recovery operator, and that we have running, is going to actually recover the metadata for the PV and the PVC. So we get to use the same data that was being used on site 1. So we have all of the data available.
Awesome.
So let's check with the DRPC what's going on. With the DRPC, it's quite good to see the state. Okay, so here we can see now that before was empty, our failover cluster is cluster 2, and the desired state is failover because I triggered that action, and the current state is failed over. So at this point, it has started moving things to site 2. So if I go into the application, we should check on the topology and see that is moved or is moving, because it takes a while to the other side. Topology. So you can see here now that right now, maybe it's a little bit small. Let me just make this a little bit bigger. It's running on cluster 2. So it has moved from one side to the other. And now we should check in our application. This is our Rocket Chat from site 1. And as you can see, is completely down. No? So you can see that it's waiting for server connection. This is not working anymore. So then I have another browser that is with our cluster 2. This is the application that has been moved to the other cluster. No?
Okay.
And for this example, I'm not using a GTM, I'm not using a global load balancer. So that's why I have different URLs, no, for site 1 and site 2. You could perfectly do this with a global load balancer, but just to make things simple, we are not currently using it. Okay, so we have site 1 failed, and let's try and refresh this. This takes a while to start, but let's see if it's available already. So here I'm going to use the same user that I had on the other side because the data is the same, no? And out of the box, we have already the cluster working
and you
on
can
this side.
see where it failed over. Yes, okay, very nice.
Yeah. So we can see here that the message is 116, the last one. And here we have also 116 and 117. So we could see there a message that we have missing, but that's just because of the switching, no, between one side of the other. And now we can see the application that is actually running in site 2. Let's see that the RTO, no, so the time that it took to fail over from one side to the other was around 6 minutes. No, this depends really on your application. The Rocket Chat takes a little bit of time to get started, to get the database ready. So that's why we could see more or less that gap. But as you can see, we have been able to fail over our application from one site to the other. And we now have it running on site 2, and we're sending messages from site 2.
Nice. Fantastic. Would you, I'm not expecting this now, but so then let's say your first site comes back. Do you fail back over? Do you leave it this way? Do you make cluster 2 now the preferred everywhere? Like, what would be the recovery path, just to talk about it?
Yeah, that's a good point. So let's say that we are now at this point. No, this is what I showed you. We have the GLB that checks OK because now the application is running, everything is up and running, it's working fine. And we say, OK, I'm going to look for a maintenance window, and then I'm going to fail back to my other cluster once it's ready. So the first thing that we need to do is remove the IO fencing, because until that IO fencing is not removed, we are not going to be able not to access the data. So that's the first thing that we need to do once we recover the cluster. And the next thing that we need to do is check that all of this cluster is in perfect state. No, so let's say that all of our pods are running fine, everything is looking good, and then we can trigger again manually the failback. So for example, if we went here into,
okay,
yeah, so the first thing
your
that
action is there a failback action or something like that, or?
Yeah, it's the one that I explained before, and I'm going to show you just a second. That is relocate. We call it relocate, but in the end, there's a failback. No, so we are moving the application back to site 1 where it was originally running. No, and it's also our preferred cluster as we have it defined in our DRPC. So let's give it a try just a moment. I don't know if we're going to have time, but just very quickly, we can just so you have a sense of the workflow. We would need to, again, edit our DR cluster. That is where we configure the fence, if you remember. And what we're going to do is we're going to set here unfenced. No? So instead of having the fence action, we're going to set it to unfenced. Then we need to check the phase again to see if this is actually, if it actually worked. Okay, so we have unfenced. If we have to relieve it, we could now see that many of these have gone away, and that's the case. So really, all of the ones that have 0, 0, as you can see here, are the ones set by the network fence. No, the other ones that are here, this is block list is also used by Ceph, for example, to control the MDS, the CFFS clients. So it also adds different blocks. But as you can see here, all of the ones that had 0, 0 are now removed, no? Meaning that we have now have removed that fence. And what I'm thinking is just to very quickly get the OCP cluster back to its current state. I'm actually going to stop and start the worker nodes very quickly.
Okay.
This, you don't really need to do this, no, but this is a little bit just to do it quicker, no, because when you fence and you remove the access to the storage, a lot of pods that are consuming that storage are going to be in crash loopback, or they're going to be in fail state, no? So really, this is a quick way that you wouldn't do this in production if you haven't fully lost your cluster, no? But this is a quick way to get everything up and running again.
Okay, so so it's interesting that you do that, because I was just thinking that when you unfence, you have to know what's going to start writing, if anything, to the storage that's now available because you took the fence away. So if you go ahead and restart all the worker nodes, you kind of hopefully take care of that problem, because ACM is not going to go make that primary yet. It's not going to go deploy this stuff again. You start fresh. I mean, maybe that's the right path out. It's like, okay, kind of resync, restart OCP1, cluster 1, so that it's all nice and new. ACM knows what's going on. Everything is still on your second site, and you don't fail back over until you're ready. Okay. Yeah, it's a little complicated with external storage, right? Like if the stretch is, it's actually, it has some nuance to it that the regional one is actually very like cut and dry about. So just something to think about.
Yeah, that's true. Here you have the fencing, that it doesn't exist, so you don't have to worry about it on regional,
because
they're completely they're different storage clusters, no? So it's completely different. Here you have to be a little bit careful with the fencing and unfencing, just to be sure that you don't access the same volume from both clusters at the same time, no?
Right. Okay.
So yes, as you mentioned, when you have the failover, everything is going to be running on site 2. You have everything on site 2. Here you remove the fence, and then you can actually do the relocate, once everything is up and running again. What I'm going to do very quickly is check in cluster 1. So I'm using context cluster 1, that is the one that we just restarted, just to check if all of the pods are up and running in ODF. That's important, because it takes a while also to get them running.
Yeah, it does. Okay. Oh, okay.
Yeah, so we still have the Nuba database initializing. So that may take a while. But the idea is that once it's up and running, we use the relocate action. And again, ACM is going to take care of deploying your app in the other side. When you use relocate, it always takes care that you don't lose any data. That's really important with regional DR. Do you know that with regional DR, you have intervals on which you take snapshots? And when you use relocate, it always takes a snapshot before initiating the movement of the application from one side to another. It's not so important here because this is synchronous, so you're actually not going to lose any data in any case, but you still have to use relocate to move from one side to the other. So let's see if this gets started. Yeah, so this is, everything is running here. And the next step would actually be to relocate. So that would be again an edit to our DRPC. That is where we actually, let me go into the hub. The hub is our ACM. And here you see that we have action failover, that we used before. What we actually want to do here is relocate.
Okay.
And if we check the DRPC again, the thing is that this takes a while before it actually does the movement, because it's going to be very sure that everything is right before it actually does the movement. So it will take a while to get everything running on cluster 1. That is its preferred cluster. As you can see, it's got initiating, and then it will move into relocating. So it takes a while to get this moved.
Okay, so quick question, or maybe not a quick question. Let's say the true cluster 1 is gone, and you rebuilt cluster 3. You're building cluster 3. There should be no reason why you couldn't come in here once it's been joined under ACM and say the preferred cluster is cluster 3. Now the desired state needs to be relocated. Would it be as simple as that?
Ideally you would set the same name. So you would call it, you will rebuild it, you will set all of the you will just deploy the operators again, and then you will add it as a managed cluster to ACM. And at that point, it will get included again. but ideally you would use the same name. If not, I think that you could still make it work. But if you remember, we have like a mirror peer relation created.
Right. Okay. You're right. There were a couple other parts that needed something. Okay.
Yeah.
All right. So if you give it the same name, it's just easier. Okay.
Yes. Yes. It's going to make your life.
Okay.
It's going to make your life easier because here we specify this relationship, no, between cluster 1 and cluster 2.
Okay.
And then you will have to build a new one with cluster 2 and cluster 3. But it's also a thing that you could actually do. But it will make your life easier just doing it like this.
Okay. Fantastic.
Okay, so it seems that it has relocated. Even if it says here relocated, it means that now the application is starting in cluster 1C, but it will take a while, not to actually start.
Right.
We can see that, just checking that the PV is again here, no, and it is available and bound. And if we do get bots for our Rocket chat, we can see that it's it still hasn't finished the deployment, no? So it's going on, and we should see at some point that is running on cluster 1, no? So we have been able to move it from cluster 2 to cluster 1, doing the failback.
Okay, and as soon as Rocket Chat finishes what it needs to do, it would be available. Okay, fantastic. Awesome.
Ideally, we can give it a try just a moment. Here we have on site 2 that is down, no, because we have moved it. And if we try here, maybe it will take a little bit a tough time to be up and running.
Okay.
Yeah, but in any case, that's a little bit the idea, to failover, fail back, and be able to have like an RPO 0 solution where you have no data loss, even when you're moving from one site to the other, and you have a full site failure. We didn't specify the failure of the Ceph cluster, but the things would be exactly the same in the sense that if only, and we showed that on episode 2, if you fail or if you have an issue with only the Ceph cluster, your applications wouldn't even notice, no? Because with the rest of the cluster that you have running on the other side, is completely transparent for the PVs and the applications consuming that storage. So you will just have like a small IO freeze during the time that it takes for the OSDs or for the monitors to recognize that the OSDs are down. That is just seconds, and then you will have everything running again. So that's why it's not so cumbersome, or you don't really need to start a failover if you have an issue only on the Ceph cluster, no?
Fantastic. Okay, so we're coming up on time. Just to recap, show 1, part 1 was the architecture of Metro DR, which means external Ceph cluster and how we use 2 clusters to connect, just the architecture. Show 2, part 2 were details about actually configuring this, how you actually make each cluster connect to your external Ceph and so on. And then this show, part 3, is an actual demo of a failover, how it actually looks using ACM. We failed over from cluster 1 to cluster 2, and then we failed back, and the app was Rocket Chat. So in the description, we're going to provide all the links needed for Rocket Chat, for everything that you've shown here, so that everyone can have it, right? And try it out themselves. Fantastic. Is there anything you want to add to this, the whole Metro DR thought process? Anything you want people to know in particular?
Yeah, I would just add that if someone is like a client that is consuming, that has Red Hat, no, and is a Red Hat client, and he has an account team, no, that he can, Red Hat account team that he can ask, and they're interested in Metro DR or Regional DR, we have like an early access program that is working currently. So we can actually do a POC with them, help them go through all of the process. We have access, because it's an early access program, to all of engineering from our side. So it's really positive, and we can get feedback from the customer, and also the customer can get his feet wet with this new technology and also start deploying applications with ACM. So it's a really good place to start. No? So I would recommend, if somebody is interested, to reach out to your account team, the Red Hat account team, and we can get this going.
Fantastic. Well, as always, wonderful show. Thank you so much, Daniel. And have a good day. Take care, everybody.
Thank you.
Thank you.
Bye.
Thanks. Bye.
Bye-bye.